Good afternoon. Today we shall discuss the specification issues in a multiple regression analysis, which means how to select the independent variable for a regression. Classical linear regression model have almost 6 assumptions. Seventh assumption is optional assumption. Assumption number 1 states that model should be linear, correctly specified, and should have an additive error term. So what do we mean by correct specification? Correct specification means that all relevant variables should be included in the equation and no irrelevant variable should be included in the regression equation. If due to any reason, for example unavailability of data, all relevant variables are not included in the equation, it results in omitted variable case and which creates biasness in the estimates. By biasness, we mean that estimated value of the coefficient is not equal to the actual value of the coefficient. On the other side, if due to any reason an irrelevant variable is added in the equation, it results in irrelevant variable case, although it does not create the biasness in the estimate. However, it increases the variance of the estimated coefficient. When variance of the estimated coefficient increases, standard error increase and t statistic fall down, which result in insignificance of the independent variables. Now we shall discuss one example of omitted variable case and one example of irrelevant variable case in eViews. If you need data in soft form for practice at your home, please subscribe the channel and type your email ID in the comment section. You will get the data files free of cost. Now here you see this is an example of specification biasness. So here we have dependent variable y and then we have three independent variable. PC is price of chicken, PB is price of beef, and YD is a disposable income. So what are these variables? You can see here that um, Y has been measured by per capita chicken consumption in pounds in a year, while price of chicken is denoted by PC is cents per pound, and then the price of beef is in cents per pound, and then the disposable income. Theoretically, the chicken consumption depends upon the price of chicken, price of beef because beef is substitute for the chicken, and disposable income. We do have a data file in the eViews. Let's move to the eView section. In this eView section, we have these variables in short form y, which is our dependent variable, price of chicken, price of beef, and disposable income. Let's run the regression. To run the regression, we type estimate in the command window. Here we will write PC, C for intercept, sorry, Y is C for intercept, then PC, PB, and then YD. If we click OK, we'll see the output here that intercept is 27.59, while price of chicken is minus 0.61. Its coefficient of price of beef is 0.092, while coefficient of disposable income is 0.24. The negative coefficient of price of chicken, which is 0.607, it shows that if price of chicken increases by 1 unit, the chicken consumption will decrease by 0.60 unit. Price of beef coefficient indicates that if price of beef increases by 1 unit, which is cent per pound, and if price of chicken per pound increases by 1 cent, the chicken consumption will increase by 0.092 pound. Coefficient of disposable income indicates that when income increases by $100, the chicken consumption will increase by 0.244 pounds. Their T statistics indicates that all the three independent variables are significant because T statistic of price of chicken is 3.86, price of beef is 2.31, and disposable income is 22.06. So this is original regression. Now let's and also please note its value of R square 0.99 and adjusted R square 0.98. Now if due to any reason we drop this variable price of beef, you know that it will result in omitted variable case. Let's run the regression and then we can, by dropping the price of beef, and then we can compare the results of this equation with the new equation, and we'll see that how dropping a relevant variable creates biasness in the coefficient of included variables. So let's name this equation equation 1, and you can estimate the equation again here. By now we will drop the price of beef variable in this equation, and now we have only two independent variable in this equation, price of chicken and disposable income. Click OK to run the regression. Now see here, if you compare the results of this equation with this one, and let's name it first of all EQ02, and see here in this regression equation, uh, let me run the first equation again here because it overwrited it by C, P, C, P, B, and YD. Now, this was our original equation in which all the three relevant variables were included. And this is the equation where we dropped one variable, price of beef. Now, let's compare the values of adjusted R square first. If we round this adjusted R square of the original equation, it is 0.9995, and this is little bit higher than the value of adjusted R square in the new equation. If we look at the value of R square, it is 0.99, here it is 0.98. It means that when we drop a relevant variable from the equation, it decreased the R square of the new equation. As we discussed here, that the main consequence of the omitted variable is that it creates biasness. So this is the main issue, that it creates biasness in the estimates of the included equation. Now I'll discuss how this biasness is created, what is its formula, and how can we calculate it with the help of the regression. See here, first of all, formula of the biasness is beta of omitted variable, which in our case is price of beef, multiplied by correlation between included variable and omitted variable. Included variable is price of chicken in our case, and omitted variable is price of beef in our case. So here you can see that because theoretically price of chicken and price of beef are positively correlated because prices move together. Therefore, the correlation between PC and PB is expected to be positive, and the coefficient of the uh, omitted variable, which is price of beef, is positive. So positive multiplied will positive will result in the positive answer. So it will result in positive biasness, which we can also verify that when price of beef was included in the equation, the coefficient of price of chicken was 0.60. When the price of beef was dropped in this equation, the price of chicken is minus 0.41 because both of these values are in minus. So minus 0.41 is more positive than minus 0.60. Thus, we conclude that by dropping a relevant variable from the regression equation, biasness is created and direction of this biasness is positive in this case. Now, we shall discuss here that what happens if an irrelevant variable is included in the equation. See here, this is our original equation in which chicken consumption has been regressed upon price of chicken, price of beef, and disposable income. And we include here one variable, and that is interest rate. We can add it here because that is irrelevant variable. No theory supports its existence in the regression equation. Note the t statistic of PC is 3.86, PB is 2.31, and YD is 22.7. And when we include this variable R in the regression equation, because it does not have theoretical support and should not have been included in the regression equation, but we included it. Now see the t statistics 3.84. Its t is insignificant. Adjusted R square has also decreased. And if you note the t statistic of price of chicken coefficient and disposable income coefficient in this equation are 3.64 and 18.72, while in the previous equation it is 3.86 and 22.02. So t statistics have also decreased. So the main effect is that it decreases the main effect is that the irrelevant variable increases the variance of the coefficient, which increases the standard error and decreases the t statistics. Now, the four specification criteria will be discussed in the and formal test of Ramsey regression specification error test will be discussed in the next video. Please subscribe the channel, and if you need the data files in soft copy, type your email ID in the comment section. You will be provided for practice purpose. And if you have any query, type in the comment section. Whenever I will be having free time, I shall reply to your query. Thank you. See you later.